Now, I want to begin by reading a little story which explains, if you like, the problem of free will very, very beautifully in an artistic way, and it's taken from this excellent book by Ian McEwan called Atonement, which some of you may have read. She raised one hand, and she flexed its fingers, and she wondered how this thing, this machine for gripping, this fleshy little spider on the end of her arm, came to be hers and entirely at her command. Or did the hand have some little life of its own? She bent her finger and she straightened it. The mystery was in the instant before the finger moved, the dividing line between not moving and moving, when her intention took effect. It was like a wave breaking, and if only she could find herself at the crest of that wave, she thought she might find the secret part of herself that was really in charge. She brought her finger close to her face and she stared at it, urging it to move. The finger remained still because she was pretending. She wasn't entirely serious. And because willing the finger to move, or being about to move it, was not the same as actually moving it. And when she did bend the finger, finally, the action seemed to start in the finger and not in any part of her mind. When did the finger know to move? When did she know to move the finger? There was no way to catch herself out. So really beautiful description there by Ian McEwan of this problem of where do our actions come from and what have they got to do with our intentions to create them, to generate them. So I'm going to use the phrase conscious intention to refer to this feeling of my desires and my sense that I'm about to perform an action, and that's going to be the key word really for my presentation today. I'm only going to attempt to ask three questions. First of all, can the experience of conscious intention be studied scientifically? What are its correlates in the brain? And most trickily, what is its function? So beginning first of all, with the question of can we even turn this experience of our own control over our bodily movements into a scientific question? Unsurprisingly, I'm going to answer yes. And you have to really begin with the work of Benjamin Libet, which is seminal here, in 1983. Now, the key point about Libet is he asked when questions. He asked questions about when things happen. And if you look at the history of psychology, really it began when Helmholtz realized that mental processes took measurable time. So asking questions about timing has always been the way that psychology has made progress. And in the Libet experiment, there are really two components. The first component is this rather unusual clock. It's very small, it has one hand, and the hand is going round every 2.5 seconds approximately. So the clock is just there to allow you to report when you have a particular subjective experience. The clock is a metric, it's like a ruler, okay? So it's there for you to tell the experimenter about your own internal stream of consciousness. The second part of the Libet experiment is that the person is going to make a voluntary action. And in the versions that we've used in my lab, it's typically pressing a button. That wasn't actually what Libet did, but it's equivalent. And the key thing about the action, pressing this button, is it's a voluntary action. The person presses the button when they want. So the instruction is, don't press the button when the clock gets to 60. Don't press the button when the clock gets to 30. Press the button when you feel like it. And that's a slightly odd instruction. It's been criticized a lot. It's a bit like saying, have free will now. And that doesn't really make a lot of sense. But let's imagine that the person is watching this clock rotating, and then suddenly they decide to press the button. So the clock's rotating, they press the button. The clock continues to rotate. It stops at a random location. And in the original version of the Libet experiment, the participant was then asked, what was the position of the clock when you first had the intention, when you first felt the urge, as Libet put it, to press the button? So Libet was asking people to effectively estimate their subjective experience of their own will. Okay? That was the requirement. So in this particular example, then maybe the subject will say, well, I felt that I was really about to press the button when the clock hand was at 23. We know that they actually pressed the button when the clock hand was at 25. We know how fast the clock is going. So we can time when they had their experience of conscious intention, as I would call it, the experience of will. And the result is really very simple, because what Libet did is, while he was getting people to report their experiences of will using this clock method, he was also measuring the brain activity associated with conscious intention. And it had been known since the work of Kornhuber in 1966 that if you place electrodes on the scalp over the frontal motor areas of the brain, you can record so-called readiness potential. This is a gradual ramp-like increase in electrical activity, which is very, very small. It's of the order of a few millionths of a volt, but it's reliable. You can measure it quite easily. And it shows this gradual increasing negativity. Notice that negative is always plotted up in EEG-type recordings, up to a point just before the person presses the button, at which point it suddenly reverses. So this really represents, this readiness potential represents the brain's preparation of the action that I'm going to make when I press the button. And the result of the Libet experiment is really quite straightforward, because it simply consists in registering on this physiological fact about brain preparation when people have the conscious experience that they're about to press the button. And on average, the W judgment, as Libet called it, W for will, what I would call an awareness of intention, occurs 206 milliseconds before the button actually goes down. Now that's really quite interesting, because your brain clearly knows that you're going to move when it begins to prepare the movement, as shown by the onset of the readiness potential, but you seem to only feel that you're about to press the button a long time later. And that gap between your brain preparing and you becoming consciously aware that you're about to press the button is indicated by this arrow here. And you'll notice that it's often over a second in length, typically over half a second, but often up to a second. Now, from the point of view of the brain, that's an eternity. That's a long time in brain time. And this result really is quite interesting, because what it seems to suggest is that the way that we live our lives, if you like, our default view about our own behavior, which we can see, for example, identified in the work of Descartes, is that we have conscious intentions. I want to press the button. This conscious intention is supposed somehow to start brain activity, the preparation of the button press, which is in turn supposed to lead to the actual button press itself. Now, that's the way that we all talk and live our lives, but it clearly implies that conscious intention has to precede brain activity, and the Libet experiment clearly shows that it doesn't. So this default view that we have is extremely dualistic, because it requires consciousness to control the brain. It's a little bit like the so-called ghost in the machine views. And since Benjamin Libet's work, I think most neuroscientists would accept that in fact what happens is that brain activity starts the causal chain. It produces conscious intention as a byproduct of the preparation of action, and somehow this brain activity creates our body movements. So the critical thing to notice here is that the brain comes first and consciousness second, whereas the way we live our lives every day is that consciousness comes first and the brain comes second. So this has been a very interesting experiment because of its philosophical implications. It seems to imply that conscious free will is an illusion, because my brain controls my actions, and I know about my actions only very, very late, only a couple of hundred milliseconds before I do them. And that raises big questions, therefore, for moral responsibility, because, for example, all systems of law which descend from Roman law have the assumption that we're responsible for our actions and therefore potentially guilty of crimes if we have the conscious intention to perform the action, the so-called mens rea, as it's called in Roman law. And it looks as though the space for mens rea is non-existent or minimal if you accept the Libet experiment. So I want to come back to that whole question about responsibility later, but I want to immediately start by thinking, well, what is this experience of being about to press the button? Does it have reliable neural correlates? And the answer, rather interestingly, is yes, it does. So you can find the basis in the brain of our feeling of conscious intention. And in an early experiment that Hackwen Lau did, and I was involved in several years ago, we did a very simple reprise of the Libet experiment in an fMRI brain scanner. And we had participants do 2 blocks of trials. In one block of trials, they had to make voluntary actions and use the clock to judge the time of their first intention to press the button. And in a second block of trials, they made voluntary actions, but they judged the time of the action itself. They judged the time not of their intention, but of pushing the button. Now, they probably got volition in both cases, but they're thinking more about volition in this case, where they're judging the time of intention, than when they're judging the time of action. And 3 areas showed more activity when they were thinking about intentions than when they were thinking about actions. And I'm just going to concentrate on numbers 1 and 3 for today. This, to my mind, is one of the most fascinating areas of the brain. It's going to come up again and again in this talk, the pre-supplementary motor area, or SMA for short. So here's the human brain, here's the back, here's the front, and what you're looking at is the view of the left hemisphere if you had simply pulled the right hemisphere away. So this is the medial wall of the left hemisphere, and this is the structure that was cut in the split brain patients whom we've just heard about from Michael Gazzaniga. So deep within the medial wall between the two hemispheres is this area which sits immediately in front of the main motor structures that actually make the muscles of the contralateral part of the body move, and in that sense is called the supplementary motor area. And it seems to be concerned not with the detail of my movement itself, but with the initiation of it, the starting of it, and the generation, the triggering, if you like, of movement. And this was particularly activated when people thought about their conscious intentions. And the second area I want to concentrate on is this one in the parietal lobe, again in the left hemisphere, in the intraparietal sulcus. So these two together seem to make up a network which is responsible for this feeling of will, this feeling of being about to. And with Angela Sirigu at around the same time, we were able to test in the Libet experiment patients who had damage in particular brain areas. These are patients with focal lesions. And what I've shown here is the time at which they experience conscious intention, or the average of the time at which they experience conscious intention, relative to a movement which is made here at time 0. And first of all, you can see that normal healthy volunteers experienced a feeling of conscious intention a couple of 100 milliseconds before they pressed the button. So that's quite interesting because it roughly replicates Libet's original result. There are many, many problems with the method that Libet used, which we don't have time to go into here, and I'm sensitive to them, but the actual result itself seems to replicate reasonably well. Now, the cerebellum is a structure which is definitely concerned with the fine coordination of our movements and with the detailed timing of how we actually move, but it doesn't seem to be involved in the conscious experience of when we're about to move. So no difference between the cerebellars and the normals. But the patients with lesions in the parietal cortex, which was one of the areas I showed you in the previous brain imaging study, have this rather interesting behavior that they appear to experience they're going to press the button only 56 milliseconds before the button actually goes down. Now, by this time, the muscle which pushes the button is probably already active. They don't seem to know about what they're going to do until they're actually doing it. They don't seem to have any advance announcement of their own behavior. Just as an important control, it's not simply that the parietal patients, for example, can't use the rotating clock or they're not concentrating, because if you ask them, when did you actually press the button, what Libet called the M judgment, all three groups are roughly equivalent. So it seems as though there are specific brain centers, here we're showing the parietal one, which are concerned with this feeling of being about to make an action. Now, a much trickier question is to say, well, what's this for and why do we have it? And what are we going to do about it? So I'm just going to take you through a number of alternative possibilities. Well, I've already tried to rule out the idea that there's some kind of brain-independent consciousness which can somehow make the brain start preparing movements and thus trigger our actions. I think we have to rule out the idea that conscious will, or the feeling of conscious will, is really about control, because that would be very dualistic. That would effectively say that you had a form of consciousness that was independent of the brain but somehow controls the brain. You'd have ghosts in a machine. At the moment, a very sort of powerful and very convincing view is the idea that conscious intention has no function whatsoever, and it's not really a proper mental state. It's just an illusion. It's just a confabulation. It might, for example, be the output of an interpreter. And the way that this sort of story, which I think is the view of Daniel Dennett and Daniel Wegner, goes, is that the brain may prepare a brain activity may begin to prepare a movement completely unconsciously. My body may then move, so I might press the button. I get sensory feedback. Patrick, your finger's on the button, you've pressed the button. And then I have to tell myself a story about it, and I interpret the fact that I've pressed the button. So in psychological parlance, I post-dict the fact that, Patrick, you've pressed the button. Oh, that's okay. You must have meant to do that. We retrospectively create for ourselves, or confabulate almost, a conscious intention to explain why we moved. And that's a very, very strong and convincing argument, and there's no doubt that we do that. We do that as part of our general interpretation of our own behavior, just as we do with interpret the behaviors of others. And the really interesting question for me is that all we do? Is there anything more to conscious intention than that? This definitely happens. The question is that exhausting everything to do with conscious intention? And I want to tell you briefly about some evidence which suggests that this is not all we do. Conscious intention is not just a confabulation. And this evidence comes from cortical stimulation. So there are very few cases where, on the basis of clinical need, it's possible to directly stimulate the human brain in the awake patient. And one of the people who does that is Itzhak Fried in Los Angeles, a neurosurgeon, who, in the process of exploring the brain to remove epileptic areas, will place grids of electrodes over the medial frontal cortex here and stimulate through successive pairs of electrodes. Now, while this is happening, the patient is completely awake and sitting up in a chair, and they're encouraged to say what they feel. And when Fried stimulated the supplementary motor area, which is the area that I told you about before, which we found was associated with conscious intention in MRI studies, the patient will say very interesting things. They'll say, "I really want to move my right arm." And the word which keeps coming up in the literature is this word urge, which I think is very odd because it even sounds like an odd word in English, people having urges. But it's the word that's used in the neurosurgical literature. So the key point is that the person has not yet moved. The person's completely still. They're stimulated completely involuntarily by the neurosurgeon through these electrodes in their middle frontal cortex, and they'll say things which sound like an experience of volition. They'll say, "I want to move, I'm about to move, I have an urge to move." And it's normally somatically specific. It normally refers to a particular part of the body. So it's something like an intention or a feeling of wanting to make a body movement. And if you turn up the stimulating current, or when Fried turned up the stimulating current, then the person actually moved, and they made the movement of the body part that they had previously felt that they wanted to move. So that's really telling, because what that says is that some kind of experience which looks a little bit like intention or volition is a byproduct of electrical activity in the supplementary motor area, and it's clearly on the main route which drives the action, because if you stimulate harder, you get an action. And I think that's really, really hard to explain if you just believe that our experience of conscious will or conscious intention is just an interpretation or just an illusion or just a confabulation to explain what we do, because at the point when the person reports this urge, they have not yet moved. They've got nothing to interpret. So this suggests to me that conscious volition is a little bit more like a perception than an interpretation. So having ruled out the idea that conscious intention is merely an illusion, I'm not saying it doesn't have an interpretative component. What then might it be? Well, I want to suggest, on the basis of a few pieces of data, that maybe consciousness has a role in prediction, and in particular through predictive learning. If we have a conscious experience of what we're about to do, this may enhance our ability to monitor our actions and the outcomes of our actions. So conscious intention may help us to answer the question, do you really want to be responsible for that? And the way that we've studied this has been to take up again an idea that Libet initiated, which is the old idea of veto. We've taken it up with a different flavor from Libet's original work, but let's think of an example from everyday life. All of us have had the experience of writing an angry email, either to our partner or to our boss, and we're really quite cross because we haven't got a pay rise or because our partner hasn't done something we'd hoped they would. And you have the feeling that you're just about to click the send button. And you feel there's a little voice in your head which says, "Patrick, do you really want to do that?" And I can tell you that the answer is no, you don't want to do that. Don't click the send button. Stop and think. Now, obviously, there aren't little voices in the head. That's too homuncular. But what we can do is consider the idea that sometimes we develop a plan of action up to a certain point, and then we stop it, we cancel, we abandon, or we inhibit. And with Marcel Brass, we studied this intentional inhibition of action, which is our name for veto. Now, the instructions here, once again, are a little bit bizarre. So we've got a classic Libet type of experiment with the rotating clock. And we're going to say to people to prepare a voluntary key press whenever you like. So press the button whenever you feel like it. But on some occasions, on freely chosen trials, it's quite up to you. Prepare the action, but cancel it at the very last possible moment before you press the button. And then please tell us, using the clock, the time of your intention to move, whether you actually moved or not. Now, the really important thing is that the judgment that the person makes of when they felt that they were about to press the button, but they changed their mind and they didn't, gives us a handle on the brain processes involved in inhibition, because we can lock our functional MRI data to the time of conscious intention. On the trials where the person inhibits, they don't move at all, but we nevertheless have a marker which tells us when to look at their brain activity. And we found just a couple of areas, I'm only going to tell you about one, which were more active on trials where the person prepared the action and inhibited than when they prepared the action and then made it. So I'm showing inhibition trials minus action trials. And it's in the frontomedian cortex. So again, notice that it's in this is the right hemisphere now, the front, the back. We've taken away the left hemisphere. You're looking at the medial wall. And deep again within the medial wall, this whole medial frontal structure seems to be essential for our voluntary action, is an area which is positively activated when we inhibit an action, but it's actually deactivated when we make an action. And this difference is significant. Now, the important point about this area here, which is associated with veto, with holding back, with stop, don't do it, is it's clearly not the pre-supplementary motor area which is involved in actually giving us the feeling of what we're about to do. The pre-SMA, which I told you about earlier, the intentional action area, is roughly here. So in a different part of the brain, we have an area which, in fact, we can show is connected to the pre-SMA by looking at the correlations of brain activity in MRI, is clearly distinct from it, and is clearly involved in this process of stopping, changing your mind about actions before they happen. So we think that this area, we don't think it makes the decision stop or go, because a decision area which decides stop or go should be active whether I stop or whether I go. We think it expresses the outcome, stop, don't do it. It's some kind of holding back process. And timing, as always, is critical in psychology. So recently we tried to get better temporal resolution to look at this inhibition task by recording using scalp electrodes over the head, the same kind of method as the readiness potential. And it's been known for a long time that the electrical activity of the brain oscillates, and it oscillates at characteristic frequencies, which are shown here. They each have funny names, but you can see that the electrical activity is oscillating relatively fast here and much slower here. And we can represent the amount of brain activity at each different frequency of oscillation as a color for each of the different frequency bands between 8 and 24 cycles per second as a function of time. So 0 here is the time on inhibition trials at which people reported they were about to press the button, which they subsequently changed their mind about and didn't press. So nothing happens on these trials at all. But if we ask the people after the trials ended, well, where was the clock when you felt that you were about to press the button? And then we retrospectively look at the brain activity around that time, it turns out that there's a reliable, statistically reliable increase in beta band power just around that moment. Now, we don't know whether that is the veto. We can't make causal comments about this. But we can certainly say that if people were just confabulating their conscious intentions, you wouldn't expect to get a reliable brain signature at that moment. So one of the interesting things about veto is that, at least in Libet's work, it looked like a kind of last gasp dualism. So Libet's work's quite interesting, because having shown that brain activity precedes conscious intention and therefore we don't have free will, he said, well, maybe we have free won't. Because maybe we know about our actions 206 milliseconds or so before we make them, and maybe that's just enough time to stop. Maybe that's just enough time for what he called the conscious veto. And you'll see why it's a form of last gasp dualism, because he thought that conscious veto has no basis in the brain. It somehow comes from outside. It's a conscious field. I didn't really have any clear explanation of what that is, which is somehow able to stop this link between brain activity and body movement. And this seems to me like letting dualism in through the back door. It's another kind of ghost in the machine. It seems to me it's much better to think about veto as simply part of a natural process that the brain uses to predict what's going to happen next and check whether that's what we really want, and if it isn't, to change tack. So I would think of veto as being much more like predictive updating, and it would work a little bit like this. Brain activity begins. It may give us an experience of conscious intention as a correlate of brain preparation. Our body will move, and normally our body moves in order to achieve an external effect. We don't normally press buttons just to keep experimenters happy. We normally do it because we want to get a piece of candy out of the machine, or because we want to have some effect on the external world. And I think that the brain can predict the effects on the external world. Possibly the same areas which are involved in conscious intention are also involved in predicting. You press the button, okay, well, what's going to happen next? And if the consequences of action, the external effects of action, seem unpleasant, well, then maybe this feedback can be used not as a conscious veto, but as some kind of neural adjustment or neural veto to modulate brain activity and thus stop the brain activity from driving the body movement and prevent the effect. So this is just a standard piece of computational motor control. Very similar diagrams are used to explain how we can manage to move our hand and reach a target even though the target is moving about in space, like a fly moving around on the window which we're trying to hit. It's just adjusting what we're going to do according to where we predict, according to the predicted target. So really this brings me to an interesting link. We want to think about our actions as being somehow down a chain in which a set of things that happen before movement, which we can generically call intention or brain preparation, somehow produce movements of our body which produce external effects in the environment. And the first part of this chain we can call volition. This is about generating movements. But the second part of this chain is pretty interesting too, because it's about how we have agency, how we change the world that we live in, how we're operant creatures. Rather than merely reacting to our world, we can produce effects in the outside world. And the concept is that our conscious volition, our experience of our own control, is intimately linked to having a model of how we influence our environment, how we can act outside our own body and act on the world outside. And I want to tell you very briefly about a study that we did a few years ago, which seems to provide a link between volition and agency. And we called this the intentional binding effect. So once again, we're asking people when questions. Once again, we've got them looking at a Libet clock and telling us where on the clock they had a particular perceptual experience. This time, the perceptual experience is a bit more straightforward. We're just going to have a beep. So the subject's not making any actions. They hear a beep, and we ask them to say, well, when did you hear the beep? And they'll give us a number on the clock, and we can work out that perhaps they heard the beep a little bit before it actually happened. And that may be because they're having trouble attending to the clock. They may not be entirely accurate, but that doesn't matter. What does matter is if now we say, okay, I want you to make that beep. You press the button, and then that will produce a beep. So the person is making a button press, and 250 milliseconds later they hear the beep, and now we ask them, well, when did you think you heard the beep? And the interesting finding is that when I make the beep through my own action, I experience it much, much earlier than the time that I experience the beep when it just happens without me making any action at all. There's a shift in our awareness, as if I was predicting the beep from the fact that I pressed the button. And you can get an exactly similar thing if you simply ask people to press a button. You can get them to estimate when they think they pressed the button, and then you can compare those estimates to a block of trials where you press the button which produces the beep. And now what you find is a rather interesting shift in the opposite direction. So people now perceive their button press as being closer to the beep than it really is. So, people perceive their button press as being closer to the beep than they did on trials where no beep occurred. So you get a perceptual shift of the action towards the beep and of the beep towards the action. And we call this a binding effect because it's as if people are trying to associate in time. I pressed the button, I heard the beep. They're binding together. David Hume told us exactly the same in 1763. So just to summarize then, in reality, action and beep are separated by 250 milliseconds in our experiments. We get individual baselines from which we calculate perceptual shifts. Here are some numbers from our paper. So it seems as though people perceive this interval, which we don't measure directly, but we can infer, as being shorter than it really is. Now, here's the interesting control condition, because now, instead of me pressing the button, this is a younger version of me, my postdoc is going to make me move by stimulating my brain using this electromagnet held over the left motor cortex. Now, when you pass a magnetic field into the left motor cortex, it depolarizes the neurons, which then causes a descending volley of action potentials, which crosses over into the right spinal cord and makes the right fingers of my right hand move. Now, this isn't exactly the same as pressing the button, but it's the same muscles. It's a little twitch, a little bit like that. And if we get the same kinds of binding estimates in the case of an involuntary twitch induced by transcranial magnetic stimulation, we don't get the same shifts and the same binding as we get for voluntary action. Now what we find is people perceive the twitch of the muscle to occur further away from the beep than when no beep occurs, and they don't perceive the beep as being shifted towards the twitch of the muscle either. It's as if the brain is saying, you twitched, there was a beep. These things are unrelated. It's not you. You're not in control. Don't put these things together. Don't bind them. So there's something about this binding effect which was unique to volition. And it's not present for physically comparable involuntary movements. How do we know that it's really predictive? Well, James Moore did a nice experiment, which is basically very similar to the experiment that I've shown you before, except that he presented actions followed by tones in 75% of trials, but on 25% of trials at random, the action was not followed by the tone. Now, we can't really ask anything about the tone here, because sometimes it doesn't happen, but we can ask about the binding of the action towards the tone. And you get the classical binding effect here when the tone happens, but you also get a statistically identical binding effect even when the tone doesn't happen. So the fact that the person was probably predicting the tone would happen, because most of the time it does, shifts their experience of when they press the button, even when the tone doesn't happen. They seem to be predicting what's going to happen in advance. And then just finally, I want to try to tie those two parts of the talk together, the part about volition and will to the part about agency and control, because we've got a couple of results recently which suggest that the brain systems involved in conscious intention, which come up in studies where you ask people about will, are also brain areas which are involved in predicting the effects of our actions. So we recently did a study in which we disrupted the activity in the pre-supplementary motor area. And you'll remember from the first part of my talk that that's the area which gives people a sensation of conscious urge when you stimulate it, and which is active when you get people to do Libet experiments in brain scanners. So this is another kind of magnetic stimulation where we take a magnetic stimulating coil over the pre-supplementary motor area, and by stimulating very rapidly for a period of time, we can transiently reduce the excitability, the activity in that brain area. So we can temporarily switch a volume knob in one brain area down. And here's a bit of technical detail. So we're delivering continuous theta burst stimulation for 2 minutes, and it's known that this tends to reduce for about 30 minutes the excitability, the contribution of the immediately underlying brain area. Now, the way that we did the binding is a little bit different in this particular task, because now you're making a voluntary action with your right index finger, and 250 milliseconds later, the effect in the external world that you're trying to produce is not a tone or a beep, but you're actually trying to give yourself a shock on your own right middle finger. And I can go later into the details of why we asked people to make voluntary actions to give themselves electric shocks. But it happened to be convenient, because it meant that the motor action and the effect were both coming out of the same left hemisphere. So the effect is this mild, not unpleasant little shock on your index finger. And in one block of trials, you have to judge the time at which you press the button, the action. In another block of trials, you judge the time that you feel the shock. So here's the results. So in physical reality, you're making an action, it produces a shock 250 milliseconds later. We always have baseline judgments where you get actions without shocks or shocks without actions, and we always use those as baselines to look at shifts for the binding effect. Now, when you start stimulating people's brains, people get lots of ideas. Oh, gosh, they're changing the way my brain works. My experience will be different. My consciousness will be altered. So you always need a control area where you hold the brain stimulator over a part of the brain which you're pretty confident has nothing to do with the task at hand. And that controls for people's knowledge that their brain has been stimulated, and the fact that the brain stimulator makes a noise, that you can feel it on your head, and so on. So it controls for the non-specific effects. And here we're holding the brain stimulator over the bit of the left hemisphere which is responsible for sensations from the leg. Now, we think that's utterly irrelevant to pressing buttons with the right hand and feeling shocks on the right hand. So really, this could be thought of as just a control condition. So you can see that we get, as before, the binding, the shift in the perceived time of action towards the time of the shock, and we get a very large binding in the perceived time of the shock back towards the action that caused it. So two strong binding effects, and people seem to feel the action and the shock as very, very closely linked. So that just replicates the binding effect. But the important point is that if you stimulate over the pre-supplementary motor area, this brain area that's involved in the experience of conscious intention and the initiation of action, you tend to weaken the binding effect. So what particularly happens is that whereas the perceived time of the shock was bound 120 milliseconds back towards the action in the control condition, it's now bound only 86 milliseconds back towards the action. So you're getting less of a binding effect. Okay, so this white arrow is longer than this white arrow. You somehow weakened the way that the brain is able to put together the action and the shock and make a single experience of I controlled that shock. So the key thing to notice here is that the big difference is in the perceived time of the shock and not the perceived time of the action itself. And that's quite interesting because it suggests that what this brain area may be doing is not only giving us feelings of conscious intentions, but looking forward to what effect those are going to have on the world. What's going to happen next if that intention goes ahead? How am I doing for time? I haven't been monitoring at all. 2 more minutes, so I think I've got a convenient jump button which will prevent me from telling you about dopamine, and I'm going to go straight to the, which is lucky, I'm going to go straight to a couple of summary slides. So the trouble is, you always have to end by saying, well, do we have conscious free will? Because if I don't end with this slide, somebody asks the question. And I think as a neuroscientist, I think I'd have to say no, we don't have free will in the Cartesian sense. So there is no way, really, as a neuroscientist, that you can believe in some kind of brain-independent consciousness or soul, which is somehow able to make my brain activity start and thus make me move. This doesn't really work. So we don't have any ghosts in the machine. But I think the brain does make us conscious of what we're about to do. And I suspect I differ here from many excellent people who have done very good work in psychology, suggesting that the brain gives us a narrative or a story about what we have just done and why we just did it. I agree with that. I agree that the brain does interpret and explain and narrate our own behavior post hoc, but I think that the brain also tells us of what we're about to do before we do it. And I think this conscious experience is something to do with predicting the effects of action. Now, there may not be time to use this prediction now, so I don't think that the kind of free won't interventive veto that Libet ended up with, I don't think that's quite right. I think that the conscious experience of what we're about to do may come too late to stop us this time, but it may be useful for next time, because a feeling of conscious experience now can be matched with the past memory. So if I remember that I intended to press the button, and then I remember that the result was a disaster, that might be quite useful for the next time that I have the same kind of feeling that I'm about to press the button. Okay? So intentions now can be matched with past memory to continue, adjust, or stop our actions. And then one thing which is really missing in all the experiments that we can do in the lab here, but I think is really important once you realize that maybe intention has this predictive effect and that we have to learn to predict, is that the will can be trained. And of course, it can actually be trained completely unconsciously. Okay? So I think a lot of what happens in education, perhaps in places like this, is that society is very carefully training people's will. Typically, it's training it quite negatively. So a lot of education is about impulse control. It's about don't do it. Sit quietly. Use your knife and fork, not your fingers. A lot of our culture is actually concerned with constraining initial impulses, if you like, prepotent reward-getting responses. And I think there's a very interesting story about how the role that conscious experience may play in this idea of training the will. So just to end, here are a few things which I think we really don't yet know at all, and certainly my experiments can't deal with, but I'd love to discuss and have the answers to. How do long-range prior intentions link to immediate intentions? So the kind of intentions that we measure in the lab are at the sub-second range. They're what I'm about to do now. They're what's called intentions in action. But as John Searle pointed out, we also have prior intentions. So I intend to go to the airport tomorrow to catch a flight home. We all intend to have a nice dinner this evening. And nobody's really got a good idea about how long-range intentions connect to what I'm doing now. Morality is a theme for this meeting, so we don't know if morally significant actions involve special types of intentions, whether they have some special access to the kind of brain circuitry I've told you about. And I think it was very interesting that Mike Gazzaniga pointed out how social we are as animals, because I think that it will be interesting to speculate on how individual will can enhance society rather than threaten it. One thinks very often of the will as being what I want, as a sort of a rampant, egoistic, individual aspect of the mind. And I suspect that that's the wrong way to think about it. I think that our sense of will has evolved with our frontal lobes and our status as social animals, because there are loads of things that we can do. We're not limited to obvious actions. We don't just respond to our environment. We have enormous flexibility in our action. That leads us to a lot of possible advantages. Creativity, we can try out new things, but it also leads to a lot of possible dangers, because what I do might have effects on you. So it's in the society's interest to allow individuals to have will, but also to constrain it in some ways. And I think the interesting question is how one can have a discourse about volition which enhances social function rather than undermines it. Thank you very much.